Theorem number 7. Let f maps A to B be a function, then f is a bisection. If and only if there exists a function g maps B to A such that f circle G equal to IB and G circle F equal to IA, and in this case G equal to F inverse. Okay, if f maps A to B be a bisection, then f inverse maps B to A is also a bisection. Then from the fifth theorem we can write f circle G equal to IB and G circle F equal to IA. Okay, next conversely, if there exists a function G maps B to A such that f circle G equal to IB and G circle F equal to IA, then to prove f maps A to B is a bisection. So bisection means 1 1 and on 2. So f maps A to B is 1 1, f maps A to B is on 2. So both we have to prove. Okay, for this take two elements in the first domain, A1 comma A2 belongs to the first set, and also we have to take f of A1 equal to f of A2. Since G is a function, so we can write G of f of A1 equal to G of f of A2. Okay, the reason is G is a function. Okay, this can be written as G circle F of A1 equal to G circle F of A2. So A1 G circle F is IA of A1 equal to IA of A2. So IA is an identity matrix, identity function. So A1 equal to A2. Therefore, f maps A to B is 1 1. To prove f maps A to B is onto, we are taking G maps B to A is a function. So we can write it as, for B belongs to function definition, for B belongs to B, there exists A belongs to A such that G of B equal to A. Since f is a function, we can write f of G of B equal to f of A. F circle G of B equal to f of A. And f circle G is equal to IB. Yes, f circle G is equal to IB. So IB of B equal to f of A. IB is an identity function, so IB of B equal to B equal to f of A. So for B belongs to B, there exists A belongs to A such that f of A equal to B. F maps A to B is onto. Hence, f maps A to B is a bisection. So in this case, we have to prove G equal to F inverse also. So now we are going to prove G equal to F inverse. For that we are taking since F from A to B, so F inverse from B to A, inverse function. Let it be equation 1. Okay, and G maps B to A. Let it be equation 2. So for this equality, we have to prove same left side function G and F inverse have the same domain and codomain. Yes, 1 and 2 have the same domain and codomain. Therefore, from 1 and 2, G and F inverse have the same domain and codomain. Okay, next thing, how to write the definition of onto. Since F maps A to B is onto, so for onto function we have to take one element in B. So for B belongs to B, there exists A belongs to A such that F of A equal to B, and inverse also. So inverse function is F inverse of B equal to A. Okay, this is equation number 3. Next, the last part, the same element. These two functions contains the same element. Since F of A equal to B, F inverse of B equal to A is IA of A, and IA is G circle F. So G of F of A and F of A is equal to B, G of B. So F inverse of B equal to G of B. So from this we can write F inverse equal to G and prove. Next theorem, let F maps A to B, G maps B to C, and H maps C to D. Then H circle G circle F equal to H circle G circle F. That is, composition of functions is associative. So given F maps A to B, G maps B to C, H maps C to D. To prove that H circle G circle F equal to H circle G circle F. Okay, there are two parts to prove. The first one is both functions have the same domain and codomain. So the first thing, the left side function is finding its domain and codomain. So first take the G circle F function domain and codomain. So for that, to find that, first take F. F maps A to B, G maps B to C. Then G circle F maps A to C. G circle F maps A to C. Okay, now H circle G circle F. For that we have to take a H. So first write G circle. Second function, G circle F maps A to C and H maps C to D. Then H circle of G circle F maps A to D. So H circle of G circle F maps A to D. Let it be equation 1. Okay, now finding the functions domain and codomain H circle G. So for that you have to write about G. So G maps B to C and H maps C to D. Then you can write H circle G maps B to D. Then H circle G maps B to D. Okay, now write F. F maps A to B and H circle G maps B to D. F maps A to B and H circle G maps B to D. Then you can write H circle G circle F maps A to D. H circle G of circle F maps A to D. Let it be equation 2. So from 1 and 2, these two functions have the same domain A and codomain D. Okay, then H circle of G circle F and H circle G circle F have the same domain and codomain. Next we have to prove these two functions contains the same element. Okay, let A belongs to capital A. H circle of G circle F of A equal to H of G circle F of A. Okay, then H of G of F of A. Okay, then for these two we can take a circle. H circle G of F of A. Okay, then H circle G circle F of A. Okay, then these two functions contains the same element. Therefore, H circle G circle F equal to H circle G circle F. Hence proved. Okay, these are the 8 theorems. In these 8 theorems, the very important theorems are 3rd theorem, 4th theorem, 5th theorem, 6th theorem, 7th theorem.